Hello. Today we're going to discuss some of the basics of mole calculations. Before we discuss the basics of mole calculations, it's probably a good idea that we understand what a mole is and what its purpose is. A mole is not unlike a dozen. We all know that a dozen means 12. For example, a dozen eggs is 12 eggs. In other words, a dozen is simply a rapid way to count to 12. If you want 2 dozen eggs, you know you need 24 eggs. 3 dozen, 36 eggs, and so forth. A fast way to count to 24 might be to refer to a case, because a case of soda, for example, contains 24 cans of soda. If you had 48 cans of soda, for example, you would have 2 cases. A fast way to count pieces of printer paper is in a ream. One ream of printer paper is 500 sheets of paper. If you had 10 reams, you therefore have 5,000 sheets. A mole is a fast way to count to 6.02 times 10 to the 23rd. For example, a mole of marshmallows contains 6.02 times 10 to the 23rd marshmallows. You might ask yourself, why are we dealing with such an odd number? And in that regard, why such a large number? The answer is the size of individual atoms, ions, molecules, and compounds. We know that they are very, very small. Because they're so small, we want to deal with a quantity, the mole, which will allow us to see the number of atoms we are holding. 6.02 times 10 to the 23rd is also commonly referred to as Avogadro's number. If I have a mole of atoms, for example, I have 6.02 times 10 to the 23rd atoms. In a similar fashion, if I have a mole of covalent compound, then I have 6.02 times 10 to the 23rd molecules. And if I have a mole of ionic compound, then I have 6.02 times 10 to the 23rd formula units of that compound. Our focus today will not be on formula units and molecules. In other words, we're not going to talk about covalent or ionic compounds in terms of the mole. We're simply going to focus on single atoms. We can use the definition of a mole, being 1 mole equals 6.02 times 10 to the 23rd particles, as a conversion. We can use that conversion to either convert from moles to particles, as shown in the top left of your screen, or from particles to moles, as shown on the top right. In other words, we can write 2 conversion factors from this inequality. Those conversion factors are designed to answer questions such as this. How many atoms are there in 4 moles of iron? In this case, we want to convert from moles to atoms. We are going to do this by multiplying by Avogadro's number. 4.00 moles of iron times 6.02 times 10 to the 23rd atoms of iron equals 2.41 times 10 to the 24th atoms of iron. In other words, 4 moles of iron contains 2.41 times 10 to the 24th atoms of iron. We can also convert in the opposite direction. For example, we might ask the question, how many moles of C, or carbon, are there in 3.01 times 10 to the 24th atoms of C? Now we want to convert from atoms to moles. Instead of multiplying by Avogadro's number, we're going to divide by Avogadro's number. 3.01 times 10 to the 24th atoms of C divided by 6.02 times 10 to the 23rd atoms gives us 5.00 moles of C. In other words, 3.01 times 10 to the 24th atoms of C constitute 5 moles of carbon. This, however, doesn't answer how a mole makes counting in chemistry more efficient. There's absolutely no way you or I are going to sit in the lab and count 3.01 times 10 to the 24th carbon atoms so that we know that we have 5 moles of carbon. There has got to be a better way. That better way revolves around the idea of molar mass. So what is molar mass? Well, we already know about atomic mass, which is the mass of one atom measured in atomic mass units, or AMU. And we know that we can, for an element, look up that atomic mass value on the periodic table. For example, aluminum, which is Al, has an atomic mass of 26.98 AMU per atom. Well, it turns out that if you have 1 mole of atoms, in other words, 6.02 times 10 to the 23rd atoms, instead of just one atom, you can't weigh them in atomic mass units because they weigh too much. We have to use a quantity called molar mass. Molar mass is the mass of 1 mole of a substance measured in grams. The other interesting thing is that the molar mass of a substance has the same number but different units when compared to the atomic mass of the substance. The atomic mass of aluminum is 26.98 AMU per atom. The molar mass of aluminum is 26.98 grams per 1 mole. In other words, the mass of 1 mole of a substance in grams is equal in number to the mass of 1 atom of a substance in AMU. We can use the molar mass as a conversion between grams and moles. We know how to weigh out grams in the lab using a balance. So if we can get to grams, and convert between grams and moles, the mole suddenly becomes a very efficient way to count atoms. How do we convert from moles to grams? Well, the molar mass, 26.98 grams per mole, in the case of aluminum, can be turned into one of 2 conversions. Either 26.98 grams per 1 mole, or 1 mole per 26.98 grams. The conversion on the left, or the first conversion I stated, used to convert between moles and grams, and the second used to convert between grams and moles. Let's look at a few examples. If we know the molar mass of a substance, we can, for example, answer the question, how many moles of aluminum are there in 17.5 grams of aluminum? To get from grams to moles, we'll use the conversion factor on the top right. In other words, we will divide by the molar mass. 17.5 grams of aluminum divided by 26.98 grams per mole gives us 0.649 moles of aluminum. Additionally, we can answer questions like, what mass of aluminum is contained in 1.20 moles of aluminum? Now we're going to convert from moles to grams. In this case, we will multiply by the molar mass. 1.20 moles of aluminum times 26.98 grams per mole gives us 32.4 grams of aluminum. Now, it is possible to combine the 2 things that we have talked about today. In other words, we can convert from grams to atoms or atoms to grams. For example, we can answer this question. How many atoms of calcium, which is Ca, are there in 35.0 in a 35.0 gram piece of calcium? We're first going to convert grams to moles using the molar mass. Then we're going to convert moles to atoms using Avogadro's number. In this case, we will take 35.0 grams of calcium. We will divide by the molar mass of calcium, which is 40.08 grams per 1 mole. And then we will multiply by 6.02 times 10 to the 23rd atoms of calcium per 1 mole. Carrying out this calculation in our calculator, we figure out that a 35.0 gram piece of calcium contains 5.26 times 10 to the 23rd atoms of calcium. These and other basic calculations involving the mole can be found in your textbook. Future videos will focus on more complicated mole problems that involve molecules and compounds as well as chemical reactions.